Hello! In this unit, we will continue working with rational numbers and we will see an example of their practical application, specifically on calculations involving fractions. In this case, we see 5/3 multiplying a large operation, an addition, where we find 5 fractions, 2/3 plus 5/6, minus 3/4, minus 7/8, plus 2/5. In the theory, we have explained how to operate with two fractions. The objective of this example is to demonstrate what to do when we have more than two fractions. As we saw with the associative properties, the associative property, in this case of the addition, allows us to add multiple fractions simultaneously. Let's now see how the calculation is done. Whenever we find a complex expression where we have to operate with many numbers, the best way to proceed is to start with what is on the inside. That is, to be more inside means, in quotes, to look for the parentheses and those who are deeper in the operation. In this case, the first operation to perform is within the parentheses. So we begin with what's inside the parentheses. Therefore, at the moment, we will disregard the 5/3, which we will copy in each step, and focus solely on operating within the parentheses. Next, we isolate the 5/3, which we will enclose in parentheses once more, and proceed to operate with those fractions. When we had two fractions, we found the least common multiple of their denominators. Now that we have 5 fractions, we'll do the same, but we need to find the least common multiple of all the denominators. So, in this case, we would consider the denominators 3, 6, 4, 8, and 5, and calculate their least common multiple, which, as we skip the calculation procedure, is 120. And what we do is rewrite the 5 fractions with their corresponding signs, and in the denominator, we put the least common multiple. The numerator can be seen to have the same numbers that were originally there. 2, 5, 3, 7, and again 2. The goal we pursue when performing these calculations is essentially to convert the initial fractions into equivalent fractions that are easier to work with and simplify. That can be done when the denominators are the same, and that is our objective. We are going to analyze what we do with the first fraction. We have 2/3, and what we do here is set the denominator to 120. To make this first fraction equivalent to 2/3, we multiply the fraction by the division of the denominators, which is 120 divided by 3. 120 divided by 3 equals 40, and what we would have left is that this fraction, 2 times 40 divided by 120, is exactly equivalent to 2/3. Is that true? Do we believe it? Well, we can quickly observe that 120 is 3 times 40, and seeing the fraction now, we realize that 40 is a common factor in both the numerator and denominator, so it can be eliminated. Therefore, all we would have left is 2/3. Then, effectively, what we are doing is finding equivalent fractions. We'll leave this one as it is, and now we'll do exactly the same with the other 4 fractions. 120 divided by 6 equals 20, 120 divided by 4 equals 30, 120 divided by 8 equals 15, and 120 divided by 5 equals 24. Once these operations are completed, since the denominators are the same, we can group the numerators directly or calculate the numerator for each fraction, and that's what we will do in this case. We have 2 times 40 equals 80, 5 times 20, which equals 100, 3 times 30 equals 90, 7 times 15 equals 105, and 2 times 24 equals 48. We now have 5 fractions, and it might seem that we've only made the first step more complicated. We had 5 smaller fractions, and now we have 5 larger fractions with slightly more complex numbers. But the correct property, and what we are looking for, is that all the denominators are the same. As they are all the same, we can combine all these fractions into one, and therefore we have the 5/3 that we are carrying over, and inside the parentheses there is only one fraction, where we have 80 plus 100 minus 90 minus 105 plus 48. Remember that the signs between fractions actually affect, typically it is done this way to simplify, and they affect the numerator, meaning that is the sign that the numerator takes. Once we reach this step, we simplify the numerator by performing the calculations, and we have 33 in the numerator and 120 in the denominator, all of which is multiplied by 5/3. The calculation is very easy, and now we apply the rule for multiplication numerator by numerator, and denominator by denominator, 5 multiplied by 33, and 3 multiplied by 120. The initial instinct might be to calculate it directly. 5 times 33, 3 times 120 to get the result. However, our objective is to express fractions in their simplest canonical form. So we start by decomposing them into prime factors before performing the calculations. The numerator can be decomposed as 5, which is a prime number, 3 and 11. We arrange them in increasing order. 3 times 5 times 11. The denominator can be factored as 3 and 120 as 2 times 2 times 2 times 3 and times 5. Once written this way, we see that the factor 3 and the factor 5 in the numerator cancel out with one of the factors in the denominator. Therefore, we are left with only the 11 in the numerator and 8 times 3 in the denominator, which equals 24. So, the result is 11 divided by 24. This is the example that allows us to see how to handle 2 or more fractions in a much more complex calculation. Thank you.